All right, we are in chapter 21, so we are going to start talking about how to use the derivative in real-life situations. Derivative, as you remember, is instantaneous rate of change. And the most common rate of change that you would come across are those rates of change that have to do with time. So, for example, if you are graphing two quantities, where x was measured in hours and y was measured in miles. So let's say you're traveling somewhere. The x-axis would record your hours and the y-axis would record your miles. Or let's say you were walking or throwing an object and you wanted to see how many feet it went after a certain number of seconds. The independent variable would be your seconds and the dependent variable would be feet. Okay? Let's say you wanted to track population over a number of years, same thing. Independent variable is years, dependent variable is population. Let's say you wanted to measure the height of a tree after a certain number of days, same thing. X is the number of days and y is the height of the tree. So all of those examples have an x variable that is measured using a unit of time, hours, seconds, years, and days. So that is the most common. You can think of tons of other examples. So when we talk about how those things change, how y changes for every change in x, you're basically putting the units of y over the units of x. So if I wanted to know how quickly my distance was changing over time, that would be measured in miles per hour. And same thing here, the distance would be measured in feet per second. That's what you're measuring with the derivative. That's what the number answer is. The population change per year. The height change per day. Okay, so you're measuring change in y as x changes a little bit. Okay, so let's look at an example of that. Let's say there is a ball that is thrown upward and it's, normally I can spell, and its height at time t is given by h of t equals negative 16x squared plus 18x plus 100. That's a nice parabola. Showing the position of the ball at any given time, or the height of the ball at any given time. So if I wanted to know the velocity of the ball at any given time, what I need to do is, well, that's change in height for any change in time. So that would be dh dt. I could also write that as h prime of t. It means the same thing. So dh dt equals the derivative of h, where t is the variable, and of course these should be t's as well. Made a lot of mistakes on this one, but you get the idea. So, so the derivative of negative 16t squared is negative 32t plus 18. And then the derivative of 100 is nothing, so I don't need that. What is the initial velocity of the ball? Well, if that's my derivative, or the velocity function, it is the derivative, it's also the velocity function. If that's what that is, then I just need to figure out what the velocity is to begin with. That's what initial means. That means when time starts, which is at t equals 0. Well, when t equals 0, then dh dt is negative 32 times 0 plus 18. So that's just 18. So that means it's starting by being thrown up at a velocity of 18. All right. When t is equal to 2, then dh dt is going to be the same thing, but with t replaced with a 2. So that's going to be negative 32 times 2, which is negative 64, plus 18. And that is negative 46. Sorry, I had to take some time to actually calculate it. I just didn't want to be wrong. All right, so that means it's now falling down at a velocity of 46. And for the last question, I'm kind of asking a bit more of a challenging question here. What is the velocity of the ball when it hits the ground? So first of all, I need to see when it hits the ground. I need to know what that means. Well, when it hits the ground, the height is 0. So I need to see when is height of t equal to 0. So you can take this parabola and either factor it or graph it or do whatever and figure out the x-intercepts, or when this parabola is equal to 0, and you should get two of them. One of them is at t equals -2, which doesn't make sense. We always start time at 0, so we're not going to have negative times. And the other one is at t equals 3.125. So in order to find the velocity at this time, I just take -32 and multiply it by 3.125 and add on the 18. And I get -82. So this one was a little trickier because I wasn't given the time explicitly. I had to figure out when that was. Okay, so when it hits the ground at a velocity of -82. All right, so those are the types of questions I would ask. Just remember that velocity is the rate of change of position, whether that's height or whether that's more of a horizontal position. All right, so feel free to ask me any questions over email, and I will see you tomorrow.